my talk today is going to be quite a bit shorter, and it's really the intention is to touch, I think, more on, give a flavour of my career and perhaps my career highlights rather than go into any sort of depth of the work I'm doing. So I'd really like to talk about the aspects of my career in machinery condition monitoring and how that links to tribology. So to start with my early career, originally I had a bachelor's degree in physics, and I went on to study for a PhD in aeronautical engineering at Southampton University. And I would say having a PhD definitely helped me land my job with Stuart Hughes Limited. Now, Stuart Hughes Limited was founded by a couple of guys called Ron Stewart and Tony Hughes, and it was actually a spin out from the Institute of Sound and Vibration Research from Southampton University. And I was really privileged to work with a company like that. Two people like Ron and Tony, they were innovators from the start, and they focused on applying vibration monitoring to rotating machinery and linking this to the condition of operational or even safety critical components within heavy industrial machines, such as drive shafts, gears and bearings. And one of the reasons I'm showing this slide here of a helicopter with hums and the world's first on it is because they developed something called the Helicopter Health and Usage Monitoring Systems, which is, or HUMS for short. And this was totally aimed at monitoring vibration for helicopter drive chains and rotors. And it was mandated for safety reasons because there were, unfortunately, now it's a bit more in the distant past, some pretty tragic accidents involving helicopters over the North Sea because of these critical failures. So there was a need to be able to monitor these significant components for safety reasons. So I was really proud to be a part of that. And this is really where my professional career started. So a long time ago, back in 1998, the company Stuart Hughes was bought by Smiths Industries, who still exists today as Smiths Group. However, about a decade later, in 2007, I became part of General Electric, or GE, because they then acquired part of Smiths Aerospace. So that's how I came about to be working for GE. So originally in my career, I started work as a development engineer, and I worked on a lot of new and emerging products. And the focus was really around sensors and sensing systems for monitoring machine critical components. And this gave me a really good grounding in multiple areas. So it wasn't just around the systems engineering, but I had to develop a deep understanding of component failure modes and the need to understand that relationship between the failure mode and the physical sensor data that we were monitoring. So very often in real world machines, components are buried deep in gearboxes and in the machines themselves. So we can't just kind of open them up and have a look. We have to stick sensors on and monitor what's going on and try and interpret from that sensor data, be it vibration, temperature, or whatever, what's actually going on. And I was really lucky because in my early phase of my career, I had some amazing experiences. I got to work on a lot of live jet engine testing. I went to places like Rolls-Royce, Derby and Bristol, General Electric, who were based in Cincinnati in the US, and one here where there's a whole test team being shown. This was at Pratt & Whitney, which was in Florida in the US, which was a pretty cool place to get to go and spend a few weeks multiple times testing out stuff. What I was doing there was testing out electrostatic sensors, which we were applying to monitor debris going into the inlet and coming out of the exhaust of jet engines. So that was really to look at kind of ingested debris that can impact gas path components, but also what debris is being produced by those components as well. So I ended up being responsible for that electrostatic sensing technology, and that actually became part of the Joint Strike Fighter, or Lightning II engine health management system. And this also kind of was the foundation of my working with Southampton University. So being part of GE, which is a very large company, it enabled us to try our condition monitoring technologies and apply them in other engineering domains. And I've got some examples here. So we developed the use of SCADA data, which is a kind of industrial controller data, but it collects things like temperatures and speeds and so on. and combining that with things like vibration monitoring data and oil system data. We applied this to GE's 1.5 megawatt wind turbine fleet. And at that time, so all these turbines are actually operational. We were monitoring more than 12,000 operational wind turbines on a continuous basis. So looking at all that data, and what we were looking for on all these turbines to see if we could detect the early signs of issues in the major subsystems of the wind turbine, such as the gearbox, which really is the main system, or the main bearing, or the oil system. I also had another example was working with General Electric gas power, so with their industrial gas turbines, to try and develop innovative condition monitoring approaches for their large industrial gas turbines, the FREng 9Es and 7Es. And what GE was trying to do at the time was introduce a sort of dual fuel combustion technology. So could they run on gas and oil interchangeably? And these obviously have these are different operating environments within the engine, and GE needed to be comfortable that we had continued operational integrity of the hot section gas path components, so the turbine and the combustors and so on and so forth. Another area where I got involved was with GE Oil and Gas, and this was around blowout preventer condition monitoring. And I think sadly we got involved in this because of the Deepwater Horizon disaster, because which I think people are probably familiar with, because there's been a film about it, although it did happen a long time ago now. But what caused that was the failure of a BOP valve. It failed. And just to give some background, it was because of the failure of the valve, then the oil well, a subsea oil well, was not shut off, and a subsequently horrendous fire ensued, which took a long time to get under control. But outside of the human and environmental tragedy, the financial losses here were somewhere around $60 billion. So what we did was look at data from underwater acoustic sensors, which were kind of listening to the valve operations, and the BOP valve system is operated during regular operational checks. So again, we were using acoustic sensors to listen to how well those valves were operating. Because this was quite a complex system, we ended up probably for the first time in my career deploying machine learning to interpret that data. And that really probably brings me to the next part of my career, which was what I'll call data science. So this was the dawn of a new era for me. I took on the role of building up a data science capability for GE within the UK. It was my first official role in the domain of data science, and partly driven by the growth of available data in the aerospace industry. And that's been quite a welcome challenge for us, I would say. And I think every industry is seeing there's so much more data available, so there's so much more we can do on that end of things. So for example, we didn't just have physical sensor data anymore. We had maintenance and repair records, fault logs. We had weather data, environmental data. So what sand or dust or aerosols is in the air when airplanes are flying. But also we had better software and better computing power. And that meant we could apply much more sophisticated techniques such as machine learning, artificial intelligence, probabilistics. And we were using that to support our commercial engines' operational and business needs. So I've talked a bit about my career within GE. I'm also fortunate to kind of have a parallel career in academia. And for many years, I supported industrial projects, kind of dual funded projects, both by larger industrial partners or UK or US government funding. I worked on multiple projects with Southampton University, and in 2010, I became a visiting professor there within the National Centre for Advanced Tribology, or nCATS, which, as we've already heard from Ling today, who's a professor there. And I do work very closely with Ling and also Professor Robert Wood, both members of nCATS, very senior members there. In 2017, I was fortunate enough to be awarded a Royal Academy Royal Academy of Engineering visiting professorship there, which would kind of endorse that role a lot more, which was very helpful. But my work with nCATS has been always around trying to connect the physical sensor data when we're monitoring components or tribological contacts and then trying to link that to what's actually going on in the contact. So is it the condition of the surface? Is it something going on in the lubrication or in the thin film? Is it something to do with where particles being generated? So very interested in those connections there. And I would say that the key collaboration areas that I have with Southampton are the applications of the electrostatic sensing that I mentioned earlier on for the Joint Strike Fighter, trying to apply those in tribological contacts, and particularly the forensic investigation, looking at the charge distributions in the contact and near to the contact. We're also very interested, which is what this slide is really showing, the integration of multiple tribosensing methods. So probably not one, this is something I've learned in my career, not one sensor tells us everything. It's that integration of multiple sensors that can tell us a lot more, inform us a lot more about what's happening. And we do a lot of laboratory testing and investigations there using electrostatics and a lot of other sensors. So that's another area. And I'm very keen to always learn from this and see, can we take this and can we adapt what we're learning in the lab to what's going on in the real world, and perhaps make those applications more effective. I'd also add that in the VP role, the visiting professor role, not only do I perform industrial liaison activities such as research project consultation, PhD supervision, I give guest lectures and mentoring. I'm also very active in GE's internship program, and I regularly recruit students from Southampton University as well as other universities. Right. I'm just going to finish off here with some final thoughts on my career. I think I've given you a little bit about my journey. I started out as a development engineer, pioneering new sensor technologies for machinery, condition monitoring and health management. I've moved into progressively more senior roles through technology and product development, and then into engineering management. But using physical sensor data and related information to understand component condition has always been important to my job, and I see tribology as pivotal to part of this, how we understand all this and how these systems interact and work. I'd also like to add a bit about professional institutions. I think throughout my career I've always recognized the value of our professional institutions, and it's a real privilege to be talking for STL today. From my side, because I did my degree in physics originally, I joined the Institute of Physics when I graduated, and eventually became a fellow. And since 2022, I've been a member of the IOP Tribology Group Committee, so I'm working there very closely with Ling. I'm also been a member of the IMEC Tribology Group Committee for something like 20 years, and since 2022, I've become the deputy chair of that committee, which is also a great privilege. For the IMEC, I am responsible for running their awards committee, the TGC, the Tribology Group Committee Awards Committee. So I'll perhaps just come back to that in a minute. And the final sort of probably my proudest career achievement to date was being elected to the Royal Academy of Engineering in 2022. I really feel very privileged and proud that my achievements have been recognised by the Academy, and I really hope that my journey in this direction has many years to run still. I really do hope so. So really with that, I'd like to say thank you all very much for listening.